Hi, my name is John McMaster here in my Silicon Valley garage.
Hey, and I'm Yusuf.
Yusuf, I hear you've been looking at rain gauges. What do you have for us today?
This last week, I actually swapped out my sprinkler controller system with one of those new fancy, connected ones. And the old one, I was going to open up and kind of just, check it out and maybe scavenge some parts from it. When I went into the rain gauge or the rain sensor, actually, where, the one that's outside that tells the controller, hey, it's raining, I found actually quite a lot of surprising engineering in that. Like not what I was expecting. I was expecting, a couple of humidity sensors, maybe, like a little level that goes up and down when the rain collects in there. But this was pretty interesting. And it's not even an old system. Like this system was installed about 3 years ago. So it's fairly new technology, I guess, comparatively. That's what I'm going to show today. And there are, I think, at least like three fairly surprising things that I found. So the one that I'm going to show you is this one right here. It's it just sits like this on your wall outside, and the rain comes in and collects in this thing. So first thing, let's actually open this up, and then I'll walk you through a couple other things. So
Sure.
it pops out like this.
And first thing I just want to say is your rain system is a lot fancier than mine. I'm just happy when mine turns on. So,
Well, it's supposed to turn off actually when the rain comes.
oh, okay, okay.
Yeah, so it doesn't waste water and overwater your plants. So, well, in any case, we can discuss that. Actually, I have some thoughts on, the old system or the new, smart controller, like how they differ engineering wise. It's actually, this is very interesting. And I think it mirrors a lot of other industries that have kind of been, reworked with technology over the last few decades. So, I think that's a pretty interesting discussion on its own. So
Sure.
here we go. You can just pop this out, and this is just a base. Keep it out here. You see, fairly simple. There used to be a 9-volt battery stuck right here. Little PCB here, and the PCB actually. I don't know if you can see this. I'm gonna try this first
Yeah, a
time.
little bit.
You see these little plastic guides that the PCB slides. It just slides in and
Yes.
out of. So,
Yes.
oh, it's stuck.
And I have to ask, do you actually remember to change that battery? Because if I got that, I would never replace that battery.
Yeah, no, and this has been out there for 3 years, and it works great. And I think I have a
Oh, wow.
couple of ideas on why the battery's lasted as long as it has, and hasn't shown any issues.
Huh.
Um, then we can get into that. I think that in itself is a big deal for like IoT devices. Like battery life is the
Oh, yeah.
major thing.
Very
Yeah,
challenging.
that what kills everything. So you see there are two little those slidey things here and here that the PCB slides into. It goes in this way. And the first interesting thing that I found is down here. Oh, you may not be able to see it, but next to the little one of the tracks, somebody took a, a soldering iron or something hot and actually melted the plastic over to hold this board in place.
Yeah, I
So
think I see a little tiny little hit there. Yeah.
right, so it's like right here. So
Yeah.
it's a semi-permanent, I guess, like fix there. But that was interesting. Like I would have thought it would be screwed in, or there'd be like some clip or something. But um, it's simple enough, I guess. The other thought I had for that was maybe it calibrates the sensor, because once you put it in, you calibrate things, and then you seal it. It seals exactly to this particular, housing in this particular PCB. So maybe that's it. That was interesting. I thought that was kind of surprising. I've never seen that being done before. Like, you're just
Sure.
heating the
Yeah.
plastic, melting it in. Um, PCB itself, fairly standard, nothing surprising. Little, I guess, IR sensor up here, IR or UV just for, daylight check, uh, light sensor. The other interesting thing is, now, how do you think, John, that they are detecting if it rains?
How do I think they're detecting the brightness?
No, the rain. So, like, how are they detecting that it has rain?
Oh, geez. Yeah, you mentioned that before. I don't know a lot about rain, but I think you can use a barometer or something like that. Isn't that the old thing you'd have on the wall, and it would like tell you like humidity and the pressure? So that was the old
Sure.
way that you do it. Like
Right,
you
sure.
captain ship or something in brass. Uh,
Sure. I mean, that's one way of doing it. Maybe you have a little, glass vial where the water collects. There's a float in there that, triggers a switch. Maybe it's like magnetic. Maybe there's like humidity sensors detecting how much rain has fallen.
sure, yeah.
This is the second surprising thing. The switch, it's literally a tactile switch that just goes on and off.
Oh, interesting.
Yeah, so that actually surprised me. I of all the things I was expecting it to be, that was not it. And the tactile switch actually is powered by this little doohickey on top. So if you look here,
Hmm.
this is a little cap. You can like move it around. There are these little slots to, I guess, calibrate it,
Okay.
right? You can like, set it to different heights,
Yeah.
right? If you pull it out, this is where the magic happens. So there's this little tower of what it looks like, maybe laminated paper, like something super absorbent, right? It's like a
Sure.
paper slash wood material, right? And the way this does it is water falls in here,
Mm-hmm.
gets into this thing, it expands, pushing the little button on the trigger.
Oh, that's cool.
It's surprising, not what I was expecting, right? And I have a little experiment here. So like if we hold it, I guess this way, I can show you, if I just hold it down, that they line up about to the height of this. And if I just take a little water and dunk it in for a second, like literally it's instantaneous, right? Like it's super
Yeah.
absorbent. And now you see
Oh, yeah. It's popped
it's
way
much
up.
taller. Yeah, yeah. So yeah, not necessarily, I guess, detecting the amount of rainfall. That's what I thought these little calibration marks were. Like you could say, oh, if it's been like half an inch of rainfall or 2 inches of rainfall. So that's not what I think this is for. This is just to calibrate the sensor to actually trigger. So if this doesn't grow much, you can just put it in and stick
Sure.
it in,
Yeah.
because I think the whole thing just gets wet. So it's like an on-off thing. It's not how much of it gets wet.
Sure. Oh, that's
Um,
cool.
yeah, so that was the second interesting thing is, like of all the things, and it's a fairly new sensor setup, like 3 years old, I guess, 3 to 4 years old. This is not what I was expecting it to be. I was expecting it to be electronic or whatever, right? Some sensor that touches water and says, hey, it rained. But this seems fairly complicated for a rain sensor, like just to
Yeah,
see
and
if oh,
and
go ahead.
when you were first asking about this, I thought if you were asking like if it was going to predict the rain, and for yeah, this is rain is actually fallen or falling. Yeah, I would have expected something much simpler, just like a capacitance or conductance, something like that. So that does surprise me a little bit.
Right, and the thing is, if you look at this, it's
Oh,
a
I know what it is.
oh,
I think I know why. I think we have the answer here. You
why?
mentioned you mentioned the battery earlier, right?
Yes,
I think that goes back to the battery. That is to say,
yes, that's what my thought was. So you have something, it's running on a battery, it needs to last forever, right?
yeah,
If this circuitry was constantly powered and was saying, hey, has it rained? Hey, has it rained? You're using up power, right? But this could be basically off. When the button is popped, it wakes up, it turns on, it sends you a signal, and then it shuts off.
yep. I think that sounds
Like
about right.
that could be, and that was my thought on it as well. A couple of things. It has a little light sensor there. Not sure how that ties in. Maybe my system doesn't use it, so I don't know how that takes a reading. Maybe there's a timer that turns off or sleeps for a while.
Sometimes they also have stuff like that for programming.
Yeah, maybe. I mean, you can definitely see the little cap here, like
Mm,
transparent, semi-transparent cap here for the light. My system, I don't think took into account the brightness level.
I see.
So, but yeah, you look at it, it's all modern stuff, right? You got ICs, you got PCBs, you got sensors, you got circuits, everything, right? But at the same time, you have, this, which I guess if it's for battery life, it makes sense. But I would have thought that there are other ways to do it, like modern ICs and like the ESP32s and all. They last quite a long time on very little power, right? Um, but generally, so this was these were the surprising things in a rain sensor. I was not expecting this, right? Um, on the whole, like on the system on a whole, right? Uh, it's fairly complicated engineering, right? Because you have this fancy sensor with all these things, moving parts and transmission circuitry and all of that. You have a special receiver unit, right? So it has like a little SD card and it has a LCD screen and it has an antenna and it has a full receiver unit. That thing is then plugged into your sprinkler controller, or the one that I had, right? And the sprinkler controller itself is pretty complicated. Lots of buttons. It's got the little, bubble button thing, keypad. It's got a big turny keypad. It's got, you know, lots of stuff. And in comparison to what I got, which was the smart sprinkler system, it's a big difference in engineering. Like the new one, obviously, a lot of the smarts, a lot of the processing is done, in the cloud or in software, right, on the device. But if you look at it, it's a very simple device. It has no LCD screen. It has one little touchpad with a couple of buttons to say run now or stop. And even the circuitry inside, very simple. You got a little wall wart which is supplying power. Um, Probably some like little switching circuits or ICs in there to send power to your sprinklers. And it's a very different kind of way to engineer. And you can tell this, even though this is like 3 to 5 years old. Yeah, that's. I think you need to talk for people to see that.
Yeah, so let me see if I can clean up the camera angle here. But yeah, this is my sprinkler system by comparison. And so this is what I was jokingly saying, I'm just happy when mine turns on, because mine is like the most basic thing almost that you can imagine for an electronic sprinkler system. It's got a clock, you can set the programs and the times. And actually, it does have this remote control, although this is almost useless because the receiver is just 10 feet away from me where this box is. So not terribly useful. But theoretically, this adds some sort of network capabilities. But yeah, this system versus yours, there's an enormous difference here in complexity and kind of the design trade-offs. But
Right.
still
and
works.
and and that's the difference. And I think this kind of mirrors the change that comes into industries, like when you have a whole new technology generation coming in, like new companies come in, they innovate, they come up with like a different way of attacking this problem, because now there are different technologies available to them, right? And it just shows that these traditional companies seem to do the same things that they've always been doing, like in terms of engineering and design and the way they work. And they don't actually go like step over to using the new technology completely. Because the one that I had actually had a big, huge like power transformer in it. And now the one that came has a fairly standard looking wall wart. You just plug it in. If that goes bad, you probably can just replace it very easily.
This is
Um,
probably a discussion for another episode, but I've been really fascinated by gallium nitride advances in power boards, in power bricks. I would love to talk about that another week.
right. That's for the USB-C stuff, right? Because they have such high power. Aren't
There's a
Do they
lot of
require
interesting.
gallium nitride, or or do some of them use it? Like,
So traditionally, the semiconductor industry started out as basically silicon and germanium. Then germanium kind of got phased out in favor of silicon. Silicon has been the gold standard for many years. Then silicon carbide started getting used, like you see in some Teslas and stuff. But silicon carbide is getting surpassed by gallium nitride pretty quickly, I think. But anyways,
okay.
um,
Yeah, and I think the more fascinating, like I have this you know preoccupation with like just how companies work and innovate, and like what makes great companies great, right? And I
sure.
think when you talk about like innovative companies, I think this is it for them to be able to cross those uh, technology, like generations, as new technology comes out, you just adopt the new ones. I think that's a big deal. Like a lot of the big companies fail to do that. And I think that's the key to the innovation part, is that you just keep adopting and moving forward, not necessarily, you're coming out with it, but you're fully utilizing what's available.
For sure. That would be a very deep conversation by itself. Maybe a topic for another podcast.
Yes.
Okay.
Definitely a topic for another podcast, but that's all I have for this. And hopefully I hope that you guys found it interesting, and we'll see you next time.
All right. See you next time. Have a good week. Bye.
Bye.